Okay, we're going to do a tough one now. Unbalanced forces. We're going to have, so it's going to be pulling at an angle, but we're also going to include tension. So your situation that you're going to run into for this type of question will be just a typical flat surface. So here's your flat surface. You're going to have one object attached to another object by a string, so you'll have your tension, except instead of having your flat force, or your force in the x direction, we're going to have this force pulling off at an angle. And that's where it's going to get a little trickier, because a whole bunch of different steps that have to occur. I'm going to tell you that that's 700 newtons. I'm going to tell you that your coefficient of friction is 0.15. I'm going to tell you that this thing is 55 kilograms. I'm going to tell you that this is 35 kilograms. And that is all I'm going to tell you. What I want you to do is I want you to push pause right now, and I want you to try this. And what I want you to find, I want you to find the acceleration, and I want you to find the tension, okay? So pause this, draw this out, and see what you can do. Okay, hopefully you push pause, because I'm going to solve it for you, and if you didn't try it, if you're just waiting for me to solve this thing, you're not really going to get anything out of it. So push pause if you didn't, and actually try it. Here's what we're going to do. We are going to go back, remember our colors here. That's my X, this is my Y, and I also have a Y there that's going to come into play. This is an Fy, this is an Fx, this is your force due to gravity. Because this thing's pulling up at an angle, we actually have to make a correction for force of friction for this one. You're still going to have your force of friction opposing this direction, and you're going to have it opposing in that direction. So we'll call this one our force of friction 1. We'll call that one our force of friction 2. So let's actually put our sum of forces statement down. What you're going to get is you're going to have Fx, and it's going to be adding to my force of friction 1. I'm going to put a star on top of this just so that I can remind myself that I've got to make this correction here for the normal force. Add that to my force of friction 2, and it has got to equal my net mass times my acceleration. I'm finding acceleration first, that's what you always do. So I should probably say that, hey. First, find A. So that's what I'm doing. I'm finding acceleration. So let's see here. Oh yes, I want to make my correction, so I'm going to go over there with my star. I'm going to say, well, I need to do something to my normal force. Am I making my normal force bigger or smaller? If this is pulling upward, which it is, and then, so my 350 newtons, which would be my normal force, or my actual normal force, is going to be reduced. So I'm going to take my 350, which is the actual weight, I'm going to subtract off my Fy. And that'll be the normal force that I use. So 350 subtract off 700 sine 18. So the normal force that I'm going to be using is going to be 133 newtons. That one is going to go into here when you're finding the force of friction. So Fx subtract mu Fn, this Fn goes there, subtract mu Fn, let's see, we'll call that Fn1, that's Fn2, equals my net mass, 35 plus 55, A. So let's start filling this in. That's going to be 700 cosine 18 minus my mu value, 0.15, and 133 newtons goes there because that's the 133 I found. So this is finding friction in this reduced capacity because of the angle, because of my Fy. Subtract that off of 0.15. Normal force for this is 550. Equals 35 plus 55, that's 80, 90. A. So 700 cos 16 is 666 newtons. Subtract 0.15 times 33. I gotta figure that one out. On 0.15 times 133, that's 19.95. I'll change that to 20 on the next one just because I didn't simplify it here. Subtract 0.15 times 550 is going to be 82.5 equals 98. So my acceleration is going to end up being equal to 666 subtract. I said I was going to change that to 20. I guess I'm not going to. 82.5 all over top of 90. So let's see what our acceleration is. 666 subtract 19.95 subtract 82.5, divide that by 90, 6.26 meters per second squared. That's your acceleration. It is all going to the right, so that means that this is positive. Now what I want to do is find my tension here. So that is my second point. We're going to find the tension. Find T. Okay, sum of my forces is going to be equal to, tension is only this section right here. That's nice. I can get rid of all of this, so that kind of gets rid of the hard part of the question. And I'm just going to say, well, tension has to add on to my force of friction 2, and that has to be equal to MA. So tension minus mu Fn2 equals MA. So tension is going to be equal to mu Fn2 plus MA. So we just got to plug in our values and we're set. So that's going to be, my mu value is 0.15. My normal force, 55 times 10, so 550. Add that to the mass that is actually causing the tension, which is 55. And my acceleration, 6.26. So I'm going to get a value for my tension, 0.15 times 550. That's 82.5. I knew that from above. Plus 55 times 6.26. That's equal to 344.3. So my tension will end up equaling in total 426.8. 426.8 newtons. That's the tension that goes way up here. 426.8 newtons. There you go. That is as tricky as I can make a flat surface with tensions. I guess, well, I mean, I could just make you do more work by throwing another line with another block or something here. I guess I could. I mean, there's tons of ways to make this more difficult. I could put an edge here and have an object come over the edge, have this pull up at an angle. And, well, but point is, if you can do this one, you're well on your way to being able to do most of the questions, or all of the questions. So there's your answer. Make sure that you're able to do that. There you go.